Howdy, howdy, this is Mr. Potter. When we traditionally look at a matrix, looking at some matrix, we're going to have rows and columns. And when we go through, we usually start at row 0, and in row 0 we'll look at column 0, then column 1, then column 2, then column 3, all the way to the end of that row. And then we'll look at the next row, so row 1. And then we'll go from row 1, we'll do column 0, column 1, column 2, column 3, column 4. And then row 2, we'll do column 0, 1, 2, 3, 4. And this is what we call a traditional traversal of a matrix. And the idea is that we're basically doing one for loop. So int r gets 0, r is less than our matrix, dot length, and r plus plus, and then we'll have another for loop where int c gets 0, c is less than mat sub r, dot length, c plus plus. And then inside this loop is where we'll do to stuff with our matrix, looking at a particular row and a particular column. So we'll either assign, or we'll print, or we'll get data out of it, put data into it. We'll do something with it. But this traditional idea that we do one row at a time, starting at the top, and go left to right, is what we call a traditional traversal. And so what we're going to be talking about in today's lesson is we're actually going to be talking about non-traditional traversals. In other words, problems where I'm not necessarily going to want to do starting at row 0, column 1 to the end of column, and then row 1, column 0, column 1 to the end of row 1, and so forth. I don't want to do necessarily top down and left to right. There may be situations where I don't want to do that. And so the first thing that I want to do is I want to show you where you can see AP problems. So I've got Google open up here, and I'm going to go ahead and go to AP Central let me get this up here. apcentral.collegeboard.com. And this is going to take me to the AP website. This is a website that both teachers and students have access to, and they have information about all of the College Board AP exams. But of course, the one we're interested in is the computer science. We're going to go to course homepages, and these are broken up by subject. So computer science is a STEM topic. We're going to choose the computer science A tab, and we're going to look at AP Computer Science A exam information. And so if you scroll down here, you're going to find the free response questions from previous years, actually dating all the way back to 2004, which was the first year of Java, and even before then, you'll see some C++. What we're actually going to be looking at today is we're going to be looking at one of the 2014 questions and one of the 2013 questions, because the idea of traversing a matrix in a non-traditional method has really been something that they've emphasized the past 2 years on this AP exam. And so I wanted to go through those two problems. So I've already downloaded these tests, but if you wanted to, you would just right-click and save link as. To save it to your desktop or wherever you're going to save it. But we're going to start by taking a look at 2014's AP question number 3. So it says a student is a school represented by the following class, and I've got an accessor for name, I've got an accessor for get count, and there's other stuff that we don't necessarily need to know how it works. But what's important is that we have these two methods, the get name method and the get absence count. And it says that the seating chart basically is a class who has a two-dimensional matrix in it with rows and columns. But the idea here is that when I'm looking at this chart, I'm going to be doing it in such a way that the students are seated in a particular order. So we're going to be given an array list of students to get students out of, if you want to think of it as a roster, as well as a number of rows and columns that our seating chart should have. And we're actually going to be putting the students in a particular order. So notice I've got Karen, Liz, Paul, Lester, Henry, Renee, Glenn, Fran, David, Danny. And I'm going to start Karen here, and Liz is going to be right below her. And Paul is going to be right below her. And then I have no more rows, so now Lester goes here. and Henry and Renee. So what's important to note is that I actually start a column at a time. And I need to make sure that a column is filled from the top to the bottom. So in other words, it's not our row and then column 0, column 1, column 2. It's the other way. It's column 0, we're looking at row 0, row 1, row 2. Then column 1, row 0, row 1, row 2. And notice, because I don't have 3 times 4, I don't have 12 students here, I'm going to end up with some empty spaces. And these empty spaces automatically get filled with null because they're not pointing to any particular object. And so what we're going to have to do is, in this first method that we're going to have to write, we're actually going to have to write the constructor. A constructor that's going to create the list, create a seating chart with a given number of rows and columns. And we're going to have to make sure that we put them in the order. We're going to fill the students column by column, followed by any seats represented by null. So we're going to talk about how to implement this. So the very first thing that I have to do is I have to make sure that I've got a matrix. And notice that they give me the number of rows and the number of columns, so I need to create a matrix of that size. Now, I already have an instance variable declared called seats, so I just need to make sure that I assign it. It's already been declared because it's an instance variable for the class. So what I need to do first is I need to say that seats gets new, and I need to make this a matrix of students, so it's going to be student with a rows and columns. So the thing is, what I've done is I've made sure this is an array of arrays of students. And then what I need to do is populate it, and remember what they said. They said that we are supposed to go column by column. So that means for my outer loop, for int c gets 0, c is less than calls c++. No, do not put a semicolon for a for loop. That is a horrible thing. Let's not do that either. So calls. And then once I do this, this is where I'm going to be doing some business. So each column I need to go row by row. So I need to do for int r gets 0, r is less than rows, r++. So at this point I'm ready to traverse my matrix. What's also important though is that I keep track of how many students I've got, because once I run out of students I shouldn't be putting any more names into the matrix. So the first thing I want to do is I want to talk about what we're going to do. We're going to keep track of a student counter. So I'm going to have an int student counter. I'm going to start it at 0. And then inside here, I'm going to add 1 to it every time I successfully put a student in there. But I need to check it first to see if I can put a student in there. So I need to say if stu count is less than, well remember, I have an array list of type student. So I need to ask student list what its size is. So dot size. And if my student count is less than that student size, then I can add it in. So to add it in, I'm going to say seats row column is going to be equal to student list dot get, and I'm going to use the get for stu count. And so what will happen is the first time I'm through the loop, my stu count is 0, so I'm going to get element 0 from this list and put it in seat 0, 0. Then the next time I'm going to go through, I'm going to need to increment student count by 1. So now if 1 is less than the number of students I have, that means I still have more students to get from my list. So I get the one student from my list, and I put it in row 1, column 0. I'll plus plus, and if that's less than the number of students I've got, then I'm going to get element number 2 and put it in row 2, column 0, and so forth. If I run out of students, if this if statement never triggers, then nothing gets assigned to that row and column. And when I declared my array seats, or when I declared my matrix seats, it filled it instantly with null. It was populated with null, so I don't need to change that. So all I need to do is close my if loop, close my for loop, close my outer for loop, and close my seating chart, and I'm done. So here's my non-traditional traversal of the matrix. I have a matrix that's supposed to be the seating charts. But what's important for me is that I start at column 0 and fill in seat 0, seat 1, seat 2. And then I go to column 1 and seat 0, 1, and 2. Then I go to column 2 and look at seat 0, 1, and 2. In other words, I'm doing the columns first, and I'm doing the rows second. And so what happens is I have to take care of the columns before I take care of the rows. So this is my non-traditional traversal of a matrix. And this is something that the AP has put a lot of emphasis on recently, that you should be able to not only deal with a matrix the usual way in rows and columns, but also be able to deal with it in a non-traditional sense. So this is our first problem. This is 2014 free response problem 3. And this is actually problem 3A. In problem 3B, you have to go through this matrix and get the students that have a certain number of absences, but the actual way that you go through to get the students isn't essential. How you traverse the matrix isn't essential, and so a traditional matrix traversal works fine. So the other thing that I'd like to do, let me go ahead and clean this up. Is I'd like to take a look at 2013. So in 2013 problem 4 we have another matrix, but notice that we're traversing this differently. For the first row I have to go from left to right, and for the second row I have to go from right to left. The third row I have to go from left to right, and the fourth row I have to go from right to left. And the first thing that I notice is that, hey, rows 0 and 2 are both going from left to right, but rows 1 and 3 are going from right to left. In other words, odd rows go right to left, and even rows go from left to right. That was the first thing that I noticed here, is this idea that I'm going to have to go through this matrix in a non-traditional way. So I've got a class called Skyview, and I'm going to have to go through this class. It contains a matrix called view that holds doubles. So I don't have to declare this. It's already been declared for me. I just have to assign it. And I'm going to have a certain number of rows, a certain number of columns, and I'm going to have a parameter called scanned. And scanned is actually going to have the data that I need to put into my matrix. So this is what my constructor looks like, and we're actually going to be writing this because this is the non-traditional traversal. And there's other stuff that we're going to have to do, like this get average. It really doesn't matter how I go through the matrix to add everything up before I divide. So that's not really necessarily a non-traditional, but this constructor definitely will be non-traditional. The idea is that on the even rows, I'm going to be inserting the elements from left to right. On the odd rows, I'm going to be inserting the elements from right to left. And it's important to note that I'm actually using an array here for the data that I'm putting into the list, as opposed to an array list. For an array list, I had to use the get method and I had to use the size method. For this array, I'm going to have to use the individual index of the array, and I'm going to have to use the array.length in order to put stuff in. So it's really important to understand that difference, because it is a difference that's very necessary to make that distinguishing point on. So we're going to go ahead and implement this Skyview constructor. What's important to remember is that I don't have to declare the variable. It's already been declared. I just have to assign it. And so what's going to happen is they're going to give me an array of data. and I have to put the data in. Notice that these first three data points are going to go in the first row, and so they go in order from left to right. Oops. They go in order from left to right. So this is going to go into column 2. But then this piece of data is starting on the first row, row 1, and so this is going to go from right to left. And so notice this data goes here, and this data goes here. So I'm going to have to take care to distinguish between the even rows and the odd rows inside of my row loop. And then notice the next element goes into this 0th element, this next element goes into the first column element, this element goes into the second column element, and so forth. So again, non-traditional traversal of a matrix. So let's go ahead and get to the code part of this. So I'm going to be given number of rows, number of columns, and a scanned array. And I need to make sure that I set up my matrix first. My matrix is going to have this many rows and this many columns, so I'm going to say view gets new double with num rows and num calls. So this is going to create a matrix of type double. And then what I need to do is I need to traverse this. Now I'm still going to start with row 0 and then go to row 1 and still go to row 2. So that part is still a traditional thing. So I'm going to set up a for loop for int r gets 0, r is less than num rows, r plus plus. And then inside here is where I'm going to have to check if I'm even or odd. If I'm an even row, I move from left to right. So if r mod 2 is equal to 0, then I'm going to do this as a traditional traversal, starting at column 0 and going to num columns minus 1. So then I'm going to set up another for loop for int c gets 0, c is less than num calls, c plus plus. And then in here, I'm going to have to keep track of which position I'm looking at. So I'm going to need some variable, let's say int scanpos gets 0. And then I'm going to need to make sure that my matrix view at element RC gets scanned sub scanpos. And so this is if r mod 2 is equal to 0. Else, and if I hit this else, then I know that I'm on an odd row. So now I need to go from the last column to the first column. So I'm going to set up this loop slightly differently. So for int c gets num calls minus 1, c has to be greater than or equal to 0, and c minus minus. And it's important to note that if I have 5 columns here, my last column is going to be column 4, and that's the column I want to start at. And I actually do want to hit column 0. If I had 4 rows, I don't want my row number to ever hit 4. So this is strictly less than, this is greater than or equal to. And then inside here, I'm going to have to say view sub r c gets scanned sub scanpos. And then I'm going to need to make sure, no matter what happens here, before I leave this method, scanpos gets incremented, because I'm going to need to look at the next element of this array and put it at the appropriate spot in my matrix. So in other words, scanpos is going to be 0. I'm going to put object number 0 into position 0, 0 and move to the next spot, scanpos plus plus. This gets done before the next iteration of, actually, I don't want it here. Let me fix that. The thing is, this is actually something that I need to do inside each of these column loops. So I'm going to need to do scan pause plus plus here, and this is going to have to be braces with scan pause plus plus. And it's always a good idea to try and run and trace your code just to make sure that everything works, because it's easy to make a little mistake like that, and it would be a shame to lose a point when you know what you're doing. When you know, hey, I've got to go to the next element here, the next element is going to go into the next available column, whether we're moving to the left or to the right. So we really do need this in two spots here. So this idea of non-traditional traversals, the idea that I'm not going to go through the matrix in the typical row column format where I start with row 0 and column 0, then go to row 1 or column 1. The idea is that sometimes I may need to look at the column before I look at the row, or sometimes the direction I have to travel on a row depends on if it's an even row or an odd row. It's important to make that distinction because the AP has really been making that distinction, especially on their free response questions. So I just thought it'd be a good idea to kind of go through these to let you see how the AP is really focusing on that. So once again, this is Mr. Potter. Thank you for watching. Have a great day.